When most people think of acid rain, they think of plants burning and dissolving. They believe that a drop of this poison would burn a hole right through their skin. In reality, acid rain is a mixture of wet and dry deposition from the atmosphere containing higher than normal pH levels. Yep, that's right. Acid rain doesn't always exist in the form of rain. Wet deposition refers to acidic rain, fog, and snow. Dry deposition occurs in areas that are dry. The acid chemicals can become dust or smoke that fall to the ground, sticking to cars, buildings, and trees. Acid rain started way back during the Industrial Revolution when factories started emitting toxic fumes with no regulations. Now it's caused by many more factors, like power plants and cars, anything that involves burning fossil fuels and using electricity. Volcanoes, forest fires, and lightning strikes also add to man-made pollution. So what now? We have all the stuff in the atmosphere. How does it exactly contribute to acid rain? The stuff that is emitted from factories and cars are gases called sulfur dioxide and nitrogen oxide. The sulfur dioxide and nitrogen oxide react with water vapor in the air to form sulfuric and nitric acid. Sulfur dioxide is emitted into the atmosphere from coal combustion. During this combustion, sulfur is oxidized to form sulfur dioxide. Sulfur dioxide then rises into the atmosphere and is oxidized again in the presence of sulfuric hydroxyl radicals to form sulfur trioxide. Sulfur trioxide then reacts with atmospheric water droplets to form sulfuric acid. Fossil fuel combustion releases nitrogen into the atmosphere in the form of nitric oxide. Nitric oxide is oxidized by atmospheric molecules like ozone and hydrogen dioxide. This forms nitrogen dioxide, which reacts with OH in the atmosphere to form nitric acid. The sulfuric acid and nitric acid are the main ingredients that cause rain to become acid rain. The acidity of acid rain is measured using the pH scale, which measures the concentration of hydrogen ions. The pH scale uses a scale from 0 to 14, where 0 is the most acidic and 14 is the most basic. Pure water is neutral at 7. Most water isn't exactly pure though. For example, normal rain has a pH of roughly 5.6 because the water vapor reacts with carbon dioxide in the atmosphere to form mildly acidic carbonatic acid before it becomes rain. The pH of acid rain ranges from 5 to 4.3. Even though that may not seem like it would make a difference, at its weakest, it can still harm ecosystems.
While acid rain may form in one area, winds can carry the pollution emissions far away, crossing national borders, sometimes over hundreds of miles. Most life is comfortable at near neutral pH 7. Change this and delicate organisms can start to die. Acid rain disrupts food chains, decreasing biodiversity. Acid rain has major influences over water and its aquatic organisms, soil and the trees that live happily in the soil, and even humans and man-made structures.
As the pH of water changes, fish eggs degrade and the young can't develop. This goes the same for plankton. They die off, disrupting the ecosystem. Organisms don't have the time to adapt to the sudden pH changes in their environment. Most acidic bodies of water don't look polluted. In fact, they can appear clear and blue. That's because there is no life. The decaying organic matter settles. Clear water disguises an unhealthy environment. All soil can resist changes in pH,
which is called the buffering capacity. However, there is a limit, and once the limit is reached, acid rain passes through the soil, unneutralized, affecting groundwater. Trees rely on the soil's buffering capacity to protect themselves from acid rain. Acidic water draws out toxins in the soil like aluminum and dissolves minerals and nutrients like calcium, magnesium, and potassium before trees can absorb them. Acid rain rarely kills a forest outright, but instead it stunts growth with years of soil degradation. Nutrient deprivation and exposure to toxins make trees likely to topple in storms and die in old weather. In harsh acid fog, leaves are stripped of nutrients and the tree's ability to resist cold are drastically reduced.
While acid rain does have its impact on humans, they are pretty minimal. Acid rain feels the same as regular rain to humans. It's even safe to swim in an acidic lake. Acid rain speeds up the natural weathering caused by rain, sun, snow, and wind. It affects stone, metal, buildings, monuments, and tombstones. It also mars automotive paint, usually shown with streaks in the car. The sulfate and nitrate particles can weaken the respiratory system and cause heart problems.
Most of the pollution that contributes to acid rain is from human activities, like the burning of fossil fuels. In fact, in the U.S., roughly 2/3 of all SO2 and 1/4 of all NOx comes from electric generation from burning fossil fuels like coal, natural gas, and oil. There have been many different approaches to solving and hopefully eliminating acid rain, like using alternative sources of energy: solar power, wind energy, hydropower, nuclear power, and geothermal energy. Other choices are to power automobiles with other sources like natural gas, batteries, and fuel cells. Companies can reduce SO2 emissions by using coal with less sulfur, washing the coal, and using scrubbers to chemically remove these gases that go into the smokestack. Power plants can use natural gas instead of burning coal. Natural gas doesn't emit as much SO2. Congress has created the Acid Rain program to help with the cause by limiting or capping SO2 emissions from power plants at 8.95 million tons annually starting in 2010, authorizing those plants to trade SO2 allowances and reduce NOx emission rates. In addition, the program encourages energy efficiency and pollution prevention.
As individuals, we can try to conserve energy by turning off lights when we are not in a room, using energy-efficient appliances, insulating homes, carpooling, riding a bike, using public transportation, or walking to avoid driving as much. It's important to preserve our natural habitats and cultural buildings for as long as possible for future generations. This can only be done if individuals and society as a whole chooses to take the effort to reduce pollution.